by and large, everybody did okay. There was just a couple of things that I want to point out where there was some minor issues that I want to make sure we address before the exam tomorrow, okay, so that we're all clear. So on problem 2, it said provide the complete mechanism for the bromination of toluene using molecular bromine and a peroxide initiator. You only need to provide one possible termination step. You all kind of had it, but you needed to kind of break it down like it was in problem 1. What is the initiation? What is the propagation? What is the termination? And you didn't label those, or many people didn't label those clearly, and it got confusing for me to see where things were going. Things were flowing logically, but difficult to follow. So we always want to start off with our initiation step, right? And I just label it IN or INIT, whatever, initiation, however you want to label it. But I said a peroxide initiator, so you could have just drawn a generic peroxide and just show that initiation. Then you needed to go down and actually label propagation. Propagation 1 would have been, right, plus toluene and I'm just going to highlight one of the hydrogens there, right? And this would have abstracted one of the hydrogen atoms, and we would have generated the carbon radical, CH2 dot plus ROH, right? Now propagation number 2, we would have had this radical coming in and reacting with the bromine, and we would have gotten CH2Br plus Br dot, right? Propagation step number 3, Br dot reacts with toluene to give should have wrote HBr, but you know, you get it. Anabolic acid, right? So this then goes back up into this step, and this continues. Now you don't have to draw that. That's understood at that point that that's going. And then you would have gone into termination. And I said you only needed to show one. And so it could have been bromine plus bromine, giving Br2, or whatever else you wanted to show. And I accepted all of those. The thing is that a lot of you tried to do this as a linear sequence of, you know, and it was not showing the individual steps, and it got confusing. So it was difficult to see what was going back. So you need to make sure that these are just laid out clearly. Okay. And then the other one that I had that I wanted to comment on was the last one, problem 5. Does anybody want to? It'll be on the YouTube channel, so you'll have it later this evening. And the last one, you're starting with cyclooctane, and you're going to not BRCl. And I tell you that more than one step is necessary, and then you have to provide a synthesis for that. Anytime you see a problem like this, you need to think backwards in that retrosynthesis. So that should have been the first thing you showed, even though I didn't ask explicitly for the retrosynthesis, and nobody really did that. You always want to do that so that I can follow kind of what you're doing in the forward synthesis, why you're picking what you're picking. So if we think about this, we know we're making a trans dichloride. And how do we make that? Do we make that by a free radical process or an electrophilic addition of chlorine across a double bond? Across a double bond, right? And so what we need is that. right? Do we have that? The answer is no, but we know we can get that by an elimination of HBr, HCl, whatever the case may be, if we can get to that. So if I can get to, something like that, all I have to do is eliminate HBr, I can get to the alkene, I can then treat that with chlorine and get the product that I want. Okay, so you should have showed that first. Now the fluoride synthesis, based on that, if I was to do it, I would say bromine, bright light, maybe some peroxide initiator. And I know that the bromine's not very reactive, so it's going to react fairly slowly and give us mainly the monosubstituted product. Right? Plus HBr. Now what do I need to do? I need to use a base to eliminate. Right? So you could pick potassium tertbutoxide, sodium hydroxide, DBN, DBU. I was pretty liberal with what I accepted. But we know we're going to do an E2 elimination. And that's going to give me the alkene that I need. Right? And so what you all did in this step, a lot of you used the wrong arrow, because I asked for a detailed synthesis, but I didn't ask for a mechanism, right? And a lot of you were giving the mechanism, okay? And so you got into the, and your mechanisms by and large were right. A lot of you picked bromine to do this, and some of you picked chlorine, and I accepted that because obviously you could put a chlorine on there and eliminate HCl, that's fine. And you were pushing the arrows pretty much so correctly, and you were pushing all the single barbed arrows. And then when you got to this, I think kind of out of force of using so many single barbed arrows, you tried to use a single barb arrow here, and that would not be correct, right? And then this, of course, we just need to treat that with chlorine gas, and that would give the product that was shown before. Okay? So that's really what I was after. When I asked for a detailed synthesis, talking about the steps, not necessarily the mechanism. Okay? So you have to talk about how you're synthetically getting there. Yeah?
What is that TO negative?
That's potassium tertbutoxide.
Okay.
Yeah, just a non-nucleophilic base.